Good afternoon, everyone. Hi, Mrs. Henningham. How are you? Um, I think, Mrs. Henningham, you should begin.
Okay, reading
We're
my
not going to
mind.
wait.
Thank you.
Right. Bless you. Take care.
Okay, good. Good afternoon, everyone. We are on the verge of exams, so we'll be starting earlier than usual. And since the pace is going to be even faster with more practice coming up closer to exam, I'm encouraging you to be on time or even early. Okay. So, God, I just want to thank you for today. I thank you for everyone who is here. I pray, dear God, that you'll give your Holy presence will be amongst us and that you'll give us the attitude to learn, give us the skill set that we need to deliver and to remember, bring to memory what we have practiced and need to recall. Okay, thank you. In Jesus' name I pray, amen. All right, so let us start. I hope everyone is feeling well. I'll give the opportunity to that one person who is not feeling well. Okay, so everyone, we're all feeling well. Nice. So we are still on differentiation. Oh, I want to scroll through for you to see. Let me share my screen. I know that some persons weren't here last, who missed a few classes. This is a good time to catch up or to remind yourself as to what was done. So I am intentionally scrolling through my document just for you to see what we have covered. We have the constant multiple rule. We have the power rule we just passed. Remember the derivative of sine x and cos x. We did the chain rule. And now we're at product and quotient rule. Can someone unmute and tell me their understanding of the constant rule? What does it mean to you? Or what does it mean to utilize the power rule or the chain rule, whichever one of those you would like to speak to? What do you recall from last class? So we'll be utilizing all of these today. Anyone?
Yes, what are you saying?
This is Shanti.
No, miss.
Go again. This is Aniki.
Yes, miss.
Okay, I need to look at the names. All right, so I'm asking you to tell me in your own words the application of the constant or the power rule or the chain rule. Just break it down, just speak and tell me what is it that you understand, the steps that you take to apply them, just that. Which one are you taking now, Aniki?
Yes, miss, I was saying.
Repeat that, please.
I didn't say I was taking any. I just didn't hear what you had said at the start of the class.
Okay. All right. So let me scroll through again. So I was saying good afternoon. After I said good afternoon. We are refreshing as to what we did last week, the 2 previous weeks, right? So I was saying, if you can remember or refresh, what does these rules say to you? How do you apply them? What do you remember about these rules? What stand out for you?
Miss, for the chain rule, the power becomes the coefficient and then the power is reduced by 1.
That's all for the chain rule?
Basically.
Basically. So I believe something else is there.
Miss, for sine x is when you're using it, it will be changed to cosine x, and cosine x will be changed to negative sine x.
Okay, thank you. Anyone wants to complete the chain rule for me? What do you recall when you're applying the chain rule? The cosine and the sine, the differentiation of those are spot on. But there's something else which we're missing with the chain rule. Are you seeing my screen?
Yes, miss.
Yes, Miss.
What is missing? All right, this is what I'm asking you guys to do now. Now is the time for you to talk. Any misconception, any idea, we're going to share it, because guess what? I might just be listening, and I learned just by you talking, from you talking and sharing. Doesn't mean that I should keep quiet, but this is how I'm going to assist my fellow students, my fellow classmates to learn. Okay, I'm trying to mute my little guardian at the back. So anyone can share what is their understanding of this? Do you all remember this one? The chain rule formula?
Yes, Miss.
All right. Can you explain what this is saying, just in case somebody's not looking at the screen?
Just like what Shante said, the power becomes the coefficient and the power is then reduced by 1.
And anything else? What about here? What is this part saying?
Times g of x.
Right. And what does that mean to you? I'm not saying what was said was wrong, you know. I'm saying that there is something more to the chain rule that we're not seeing. We're not saying, that is it. We're not saying it. Anyone else want to give a try? Sorry, I'm trying to get my background noise free. Okay, let's see. So we're stuck at the chain rule. I guess we are not understanding what is required of us in the chain rule. So Kimoli, you want to assist us? What is required in the chain rule? It goes one step further than what was said. It is not just.
I think you're referring to the part that you're supposed to multiply by the differential of the inner function. Is that what you're talking about?
Yes, Kimoli. So you want to put everything together for me? Thank you very much, Kimoli.
So
When
the
you're
coefficient,
differentiating, mhm,
when you're differentiating by the chain rule, the power becomes the coefficient and it's reduced by 1, and you times it by the differential of the inner function.
okay, thank you. So who has benefit from that? You can type into the chat. It's the same thing that which has been said, it's just one step which was missing. One step. Somebody tell me about the power rule, which is also embedded in the chain rule. A portion of it is included in the chain rule. What is that saying? What does the power rule say?
Miss,
See, the power rule means when you multiply the function by the derivative of the inside something.
You multiply the function by the derivative.
Yeah, of the. Never mind.
Come on, try again. Hold on, let me see who's talking. Hold on. Somebody shout out the earning because I want to see who's talking. None of that around here. Who was it? So nobody now talking who it is. Can you speak again, please? I need to see who it is. We need to clarify it.
Miss, I was just saying the last part of the chain rule that Kimoli just stated about multiplying the function by the derivative. That would fall under the power rule, but in the power rule case, to apply the power rule, the power or coefficient must not equal to 1.
All right. This is Aniki, right?
Yes, please.
All right. We're going to talk it through. All right. You're saying the exponent, the index should not be 1. That's what you're saying?
Yes, miss.
Why not? Why can't it be 1?
Because
So
they're
when
going
you-
to have to take 1 away from the power. They would get 0. So that would.
It is fine. It is fine to have 1, but you know what the result will be. So it is fine to do that. It's a part of the problem. So what is the derivative? What is it when you're differentiating a function? When you're differentiating a function with 1, what would be the result?
The function itself.
The function itself?
Miss Zero.
You sound like you're guessing.
No, miss, I'm not guessing.
You're not guessing? All right. Okay, Shanti. So when you have a number or an x value raised to the power of 1, right?
Yes, miss.
The solution is, what is the derivative of it?
The quotient.
This?
Miss, what you say? That's where you ask again.
That's what I'm asking again. When you have x being raised to 1, what is the derivative of that?
Oh, the quotient, the value in front of the x.
Right. So that's what I'm saying. It is okay if you have an index of 1. It is okay. It's how you apply it. So with the power rule now, it says x raised to the power of n. The derivative of it is the index becoming the coefficient and multiplying that term. And then what you'll do with the index, you're going to take 1 from it. Is that what this is saying?
Yes, miss.
Right, and look below it now. The x, what is it? What is the index of this x?
1.
1. Right? So you're saying that the derivative of, so what is the coefficient of this term here?
1.
1. Right. So when you have 1, the index 1, and you're subtracting 1 from it, you're left with the coefficient, which is 1. Okay? So don't be scared in applying what you know. Don't doubt yourself in doing that. Okay? It's either you know it or you don't know it, and we're going to get to that point of knowing it for exam. Anything else you'd like to share?
The product rule is the first times the differential of the second plus the second times the differential of the first.
Which one is that?
The product rule.
The product rule. Say it again for me now.
The first time the differential of the second plus the second time the differential of the first.
All right. So since you gave me the product rule, what is the quotient rule?
Miss, the quotient rule is the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator divided by the denominator squared.
Nice. Is there any question in relation to what we have discussed just now? Anything you'd like us to share? So what I believe I will do for next class is just share a topic on the whole indices. Okay. So let us put this in practice. Differentiate sine x plus cos 4x with respect to x. I know many of you have reached a point of differentiating by sight. We can share together. So let's proceed. When we're differentiating sine x, what do we get?
Cos x.
And when we are differentiating cos 4x, what is the solution there?
-4 sine x.
Negative 4 sine x. Sine.
Negative 4 sine. What's the ending?
No, miss, just negative 4 sine.
Okay. Negative 4 sine. Let's see. Does anyone has anything different for cos 4x? Is it negative 4 sine?
Negative 4 sine x.
We're missing something. Why are we changing the term 4x? What should we do with this term?
It's supposed to remain 4x.
Right. So the solution for that part is what? For the entire, this
It's
second,
-4 sine 4x.
Negative 4x sine.
hold on. Are we saying this, Camille?
Miss, I'm really not sure.
Right, Anil? Why you're not sure? You're practicing too much.
Maybe.
Maybe. Okay. Is there anyone who is unclear as to how to solve this question?
Me, miss.
Tanisha. Tanisha,
Yes, miss.
you were here last week, the last two classes, were you here?
Miss, I was here for Saturday class and Friday, yeah.
All right. So the rule is that, John Mark, can you share the rule with Tanisha? I think Tanil just having a little moment there. She'll catch on.
What room is I just came in the class.
I think I just, okay, that's fine, John Mark. But what I was asking is, when you're differentiating sine x, what is the rule, or what is the solution when you're differentiating sine? The differential of sine is
Cosine.
cos, and the differential of cos is negative sine.
Is negative sine.
Right. And what did we learn when we say we're differentiating cos 4x? The coefficient of the x term, we're multiplying sine by it, so it's negative sine times 4, and we write back the term itself. We cannot trouble this term. Is that so? Do you recall sir saying that? Well, guess what? This is how it should be, okay? So you minus cos, to differentiate cos, it will give you minus sine, sorry. And then you're taking the coefficient of this term here, and you're multiplying the sine, right? And then we're writing back the last element there, right? So we need some more practice on it.
Miss, I understand it now.
I know you just need a little break. Let us try another one. Let me look back and see if an example sir gave, right? You remind me of an example that sir gave with this cos. And we could even create one for ourselves. You have cos 2x, cos 4x, cos 5x, cos raised to the power of 3/2. You have to, when you're differentiating it, you have to bring that value to become the coefficient. You're multiplying that sign by it. Okay? Let me scroll back up for you to see what we did last class. Let's see. Here. Comes back to memory. We're differentiating sine 2x minus 3, right? And we are saying to differentiate sine, it is cos, right? And then we're differentiating in the bracket, which is 2 to become the coefficient here. And then we write back the term. So the correct thing is that we're differentiating in the bracket to become the coefficient. And then, what rule is this though? What rule? This looks like a rule other than the fact that we're doing sine and cos. Isn't this the The power rule, yes. But isn't this a chain rule?
Yes, miss.
Okay. This is a chain rule where you take the differential of this function here and you times it by the other function. This looks like it. All right, let's continue. So we have revisited the cos and the sine to differentiate the cos and the sine. So let us not mix it up now. So it is the to differentiate sine is cos. To differentiate cos, it is minus sine, right? And to differentiate the term here, this is raised to the power of 1. So this result will become what will multiply the entire this sign by. So to differentiate here 4x, you get 4. That's why the 4 comes here. And then you'll write back the term. Okay, let us try another question. So I'll start showing you how to work it out. Differentiate 2x cubed raised to the 3 power plus 2 all over 2x plus 1. And we're reminding you of the quotient rule. Why are you applying the quotient rule here? Well, I'm giving the suggestion to apply the quotient rule, but why would you apply the quotient rule here?
Because there's a numerator and a denominator.
Nice.
Yes, miss.
Okay. So what will be the result here? What's the first thing you're going to do? Any problem?
To differentiate.
You're going to define the function, label the function, call it a name, right? So y equal the function. And the next step, you proceed to differentiate. So what is your next step now?
Write down the denominator.
You write down the denominator first. Okay. So let's go with the rule. Ready? I'm giving you 2 minutes to do this question. Are we ready?
No, miss.
1 more minute. Okay, let's begin. What is the result? Are we getting?
Miss, I have 8x cubed plus 6x squared minus 4 all over 2x plus 1 squared.
Sounds like it. Anyone else?
Miss, I got the same
Thing,
thing.
Miss.
Same
Okay,
answer.
nice. Anyone got something different? So it's a denominator.
Miss, can you repeat the answer? I didn't hear what you said.
But Tanisha, what did you get?
Miss, I got 8x squared plus 4 over 2x plus 1 squared.
Let us discuss. What is the rule?
The
Miss,
denominator times the differentiation of the
of the
numerator
numerator.
minus the numerator times the differentiation of the denominator.
Go again, John Mark.
The denominator times the differentiation of the numerator
Mhm.
minus the numerator times the differentiation of the denominator all over the denominator squared.
Wrong. I don't remember.
Go ahead. Tell me what is wrong now, Aniki.
I don't remember.
You going to tell the examiner you're joking? Are you Aniki?
No, miss, I just not me and some miss incorrect, but me just say wrong.
Okay. So what is incorrect about what he said?
Miss, not incorrect. Do what you say.
Okay, okay. Sorry, I'm a bit slow today. All right. I'm a bit slow today.
Every day,
So,
miss.
Tanisha, where
Yes,
are
Miss.
we in the working out of this question?
Miss, I'm finished.
But you got something different. Let's go through. So we have the denominator times the differential of the numerator, right? And Tanisha, how did we get?
Oh, Miss, I wrote something wrong. I just realized.
Okay. Is there any issue with anyone else? So
Yes,
we
miss,
might,
shouldn't that be 6x squared?
let's see. Where are we? Where is the error now? 2x times 6x squared, right? Minus, this is a numerator, times 2. Let's see. 12x cubed plus 6x squared. All right. So this should be 6x squared. That's what you're saying. Okay, let me see if I can put on the, hold on. Nice. So this is 6. Insert. 6x squared. Who's paying attention? Nice. But here am I having something on paper, not on the slide. That is okay. So this is it, Shante,
Yes,
Antonio.
Miss.
Oh, all right, nice. So who got something different? Are we all on the same page now?
Yes, miss.
All right, so let's go to another question. What is, obtain an expression for dy over dx if y is equal to x squared times, in brackets, we have 4 minus x. 2 minutes. I know some people already write down the response already, you know, so 2 minutes, 6:15. John Mark,
Yes, miss.
I heard somebody said in the chat, well, I read it. Who for son that? Oh my gosh. All right, John Mark. So question 2, who is assisting me with question 2? Somebody who I haven't heard from since afternoon, who is assisting me with question 2?
Eight x minus x squared.
Repeat that answer.
8x minus x squared.
8x minus x squared. Is there another response? Thank you, Aniki.
Miss, I have 8x minus 3x squared.
You have, repeat the response. Let me note it.
8x minus 3x squared.
8x minus 3x squared. All right, anyone else? we're going to work it out together. John Mark, what is your response? Kimoli?
Miss, I have 8x minus 2x squared minus x cubed.
8x, repeat the response, I'm writing it down.
8x minus 2x squared minus x cubed.
Okay. All right. Thank you. All three responses I've received so far. 4. One of them agreeing to 8x minus 8x squared, but let us work it out. All right. Let's see. Let me see if I have enough space to annotate. All right, so we're using the product rule. Can somebody remind me of the product rule? What does it mean to you?
The first times the differential of the second plus the second times the differential of the first.
All right, so let's write it down as how we're saying it. Unable to annotate. Okay. Let's work it out. I'm going to say one line. The first times the differential of the second, right? The differential of the first times the second. All right, so let us take it one step at a time. So we're writing back the first term, right? Everybody's with me?
Yes, miss.
Who got something different for the differential of the second term? I got -1. What did you get? Did you get something different?
Miss, I did someone making mistake, miss.
What was the value put here?
1.
Who told you that that's a mistake? Who told you that that's a mistake?
Because I have negative x, so obviously there will be a -1 in front of the x.
Okay, all right, fair enough. Fair enough. All right, so we're plussing. What are we plussing? The differential of the
First.
Is that differentiated correctly? 2x.
Yes, miss.
And we're timesing it by
The second.
the second. All right. Is everyone with me so far?
Yes.
Yes, miss.
All right. Can you share what other error was made at this step? Okay. When you're able to identify the error, you know that you will not make it again. All right. So here we have -1 times x squared, giving you negative x squared, plus 2x times 4, giving you 8x, minus, right? 2x times minus times x gives you what? 2x squared minus negative 2x squared, which works out to be grouping like terms, negative x squared minus 2x squared, giving you negative 3x squared, and you are keeping plus in the 8x.
Miss, I almost got that. I just forgot to put the -1. So I got initially 3x squared plus 8x.
3x squared plus 8x. So we have to keep this sign in mind, okay? Good try. And is there anyone else that had a misunderstanding here? All right, let's try number 3. Two minutes. Any volunteer?
Miss, I got 3 minus 3x squared minus 2x.
Repeat that response. The solution 3 minus
3x squared
mhm,
minus 2x.
minus 2x. Okay. Any other solution?
Miss, -3x squared minus 2x plus 3.
Which is the same thing. Okay.
Miss, I
Yes.
got x minus 3x cubed.
X minus 3x cubed. Okay. I'm noting the responses. And I'm asking you, wherever an error is made, I want us to share it, okay? This is a class for us to learn in the next 2 minutes. This is a session for you to voice and let us know where we're going wrong, okay? Anyone else? Patrine, is everything okay?
Okay.
Are we together on this topic?
It's not completely. I just reached that. I'm just picking up right now.
Okay, I understand. Chanel,
Yes, miss?
we're good?
So far, yes.
Okay. Amelia, Miss Amelia? Okay. All right. So let us repeat the rule first. Any volunteer? What is the product rule?
The first times the differential of the second plus the second times the differential of the first.
Okay, what is the first in this situation? The first what? What is the first? What is considered the first?
Miss
Anyone?
Sarah said any one of them can be the first.
And repeat that?
Any one of them can be the first one.
Okay. But we're taking this for those persons who are not catching on so quickly. Let us label which one as the first. Which one are we labeling as the first?
3 minus x squared.
Okay. And the second to be x plus 1, right?
Yes.
All right. I have a question for you, Tanil, but I won't ask it at this point in time, after we're finished. All right, so what's the next step after identifying the two functions?
You're going to write down your first function, and then you're going to multiply it by the differentiation of your second function.
Mm-hmm.
And you're going to add it to the second function and multiply it by the differentiation of the first function.
All right. So the first function, 3 minus x squared, that is a function itself. Right, Patrine? What is it, the different, what is the second function to differentiate the second function? What do you get? You get the 1, right? Do you see how you get the 1? Patrine? Do you see how you get the 1?
Yes, miss.
Okay. And you write down this plus, you write down the second function and the derivative of the first, right? Are we all clear on this line?
Yes,
So when you're
miss.
differentiating a
miss.
constant, when you're differentiating a constant, it's 0, right? When you're differentiating x raised to the 1, right? In the power of 1, it's what? 1, right? Because remember, same rule applies. You're using the x raised to the 1. Even if you're going to apply the chain rule, it's the same thing. It is 1, that's a rule. X raised to the 1, when you're differentiating it, it is 1. Okay? All right, so we're all clear with the first line. Let's move on. So what we are doing now is multiplying across 1 times 3, and we're writing it 1 times minus negative x squared, and we're writing it down, okay? And we're doing the same thing, we're expanding. Are we all clear with the second line? So it's negative 2x times x, negative 2x times 1. Right? And we're grouping like terms.
Yes.
Go ahead.
So can tell me how you get the negative 2x, please?
How do you differentiate the first function? When you're differentiating a constant here, what is the end result when you're differentiating a constant? Zero, right? And what is the rule when you're differentiating x squared? The power rule. So it's go ahead.
Multiply the constant by the power and then subtract 1 from the power.
And what is multiply the constant by the power, right? So what is a constant here? The coefficient here
1.
to the x squared. What, and
1.
then try again. What is the coefficient to the negative x squared?
Negative 1.
Okay. So are you seeing that? So it's 2 times negative 1 and you're minusing 1 from the power. So hence you're getting 2x, negative 2x, because this is saying it's raised to the 1, okay? Are you seeing that, or do you want me to type it out? Come on, we're over time. You're seeing it, Green?
I'm seeing it, miss.
All right, Tanisha. All right, so we're grouping like terms. So the x squared, negative x squared, we're grouping like terms. We'll give you the negative 3x squared minus the 2x plus the 3. All right. So to close off this session, can we all just refresh the rules? Let's call on a name. Monisha, I haven't heard from you. Can you remind me of the quotient rule? Monisha, go ahead.
Is it
Go
something
ahead.
like the numerator? Miss Erin?
Yes, I'm hearing you. Go ahead. Just remind us of the quotient rule. You have to practice your song, you know.
Miss the numerator multiplied by Miss what word?
All right, I'm going to ask one of your colleagues
Miss,
to
I have
ask.
a question first.
Go ahead.
Miss, how you get the +3? And
This 3? This one?
yes, miss, for the last part where you get +3.
This 3?
Yes, miss.
Okay. 1 times 3. 1 times 3, we're expanding. 1 times negative x squared. See?
Oh, yeah, I realized, sorry.
All right. Tanisha, can you repeat for me the quotient rule? Can we?
The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator over
over
the denominator square.
Nice. Thank you and good try. So can somebody remind me of the chain rule? I think we're ready for sir. When you're ready after this, sir. Someone remind me.
Miss, the exponent will become the coefficient of x, and that exponent will also be reduced by 1.
Tanil, say it again, Tanil. Say it again.
The exponent will become the coefficient of x, and the exponent will also be reduced by 1.
Thank you, Tanil. Tanil, you want to give us the product rule? I just love hearing when you participate.
Okay, Miss. So for the product rule, it's the exponent will be multiplied by the function, and then you're going to differentiate that function, and the number that you get when you differentiate the function, you will multiply by the, so I don't know how to explain it.
Is this the time that I take over now, Miss? I don't know. Miss Henningham, are you hearing me?
I just recognized what was happening. I was teaching myself.
Okay, I was wondering.
Oh
Right. Okay,
my
finish off.
Oh my gosh, thank you, Tanil. My apologies, everyone. So we were saying the chain rule, chain rule, the exponent will become the coefficient, right, of the function, and then we're going to differentiate the function times differentiate the function, right? This just right? So this is what we have here. So we have the differential, the function, the exponent will become the coefficient, so multiplying the coefficient by the function, and then we're going to differentiate the function and times it by the original function, right? So just like what we have here, if we were here last week, but yes, it's just threw me off big time. Yes, sir, ready for you.
All right,
Sir?
thank you.
Yes, sir. If you could just remind us in your terms, the chain rule, and I think we'll be fine.
All right.
That's where we
So
are.
it's the first. Okay, no problem, no problem.
Mhm.
What I'm happy about, and I'm really very excited about this, is that you guys learn how to sing. You guys know the rules. You know how to differentiate now. Mrs. Henningham, those who came on Saturday did a fabulous job. Oh my goodness gracious. Me, I'll promise when I told them cheese strips, because I mean they did so well, and you know, boy, I'm really very proud. I'm really very proud of them, man. So remember, when you have the chain rule, think of a chain. You are differentiating individual terms. These terms are separated by either a positive sign or a negative sign. In the chain rule, you can have the quotient rule coming up in there. You can have the product rule coming up in there. You can have the power rule coming up in there, right? Just remember the chain rule, you are differentiating individual terms. Those terms could be an exponential function, a logarithmic function, something involving a quotient, a product, um, or the power rule. So as a result of that, listening on, I decided that I'm going to be sharing something with you. And I'm going to be, oh dearest, that's the wrong document. You see when you get excited? And I want you to, oh goodness, number 16. I think it was number 16 that I wanted you to do for me. Number 13. So I want you to do number 13 for me because this is an example of the chain rule. But in this chain rule, I have a normal differentiation here. Then in this chain rule, the second term, because remember the chain rule is separated by either a positive sign or a negative sign. The second term in this chain rule is a quotient. The third term in this chain rule is a product. So you can have a chain rule which includes all the different rules of the differentiation. So I'm going to give you 5 minutes to work on question 13 for me. And then remember, guys, that we don't have the time to sit and dress up all of these stuff. So I'm going to be moving into another area of the differentiation so that I can finish off unit 2 and move into unit 3. Hopefully I can start unit 3 today. Not unit 3, yeah, unit 3 today. So I'm giving you 5 minutes to do this, and I'm going to give you a second one based on what Miss said. I'm going to give you a second example, and we'll see what can happen. So start for me, please. 5 minutes.
Semi-finished.
Wow, very nice. 1 more minute, guys.
Finish, sir.
Very nice, very nice. All right. What's the answer that you got? Anyone? Someone?
So I got 12x squared plus 1 plus -2 over x squared. Well, that would have been -2 over x.
Continue.
Sure, that's all.
Okay, all right, thanks. Anyone else? Everybody agree with Aniki?
Yes, sir.
Is there any difference? Anybody got anything different than what you got?
Yes, sir.
Yes,
What you got?
sir. Sir, I got 12x squared minus 2x raised to the minus 2 minus 3x plus 1 in bracket minus 3 open bracket x plus 1.
JV, JV or Shanti, what you got?
Sir, I got 12x squared plus negative over x squared minus 3.
Okay. Okay. So part A, everybody got the 12x squared, good. Part B is a -2 over x squared. I hear somebody say plus -2 over x squared. I can work with that. And part 3, I got -6x minus 3. So together, this is what I got for my answer.
Yes, sir.
That's
Sir,
what you
can you
got?
go through it, please?
Okay, I was hoping that somebody would ask me that because it don't sound too righteous. All right. So what I did for emphasis was to call part 1 my first term, my second term, and my third term. You all agree with 3 times 4 is 12x squared, agreed?
Yes, sir.
Yes, sir.
All right. My 2 over x is going to be 2 to the come on. It's going to be 2 to the negative first power. Sorry, my system was slowing up on me. All right. So my 2 to the second, 2x to the -1. You recognize this portion here. Everybody agrees that 2 over x is the same thing as 2x raised to the negative first power?
Yes, sir.
Yes, sir.
-1, thank you. -1 times 2 is -2. And I'm subtracting 1 from the power, minus 2 raised to the negative second power. I heard Tantan leaving the answer as a negative power, but remember, we don't leave our answer as negative, so we're going to reconvert it to be -2 over x to the +2. Everybody agrees with this term?
Yes, sir.
Yes, sir.
All right. Let us look at the other term now. The other term is going to be,
Sir, so what you're saying is that the +2 over x is now 2x minus to the negative power?
yes, ma'am.
And then when you come down here, it's turn to a -2 instead of 2?
Yes, ma'am.
Okay.
No. Please do not unmute. This is a teachable moment. Can you unmute for me, please? Do not mute. Can you unmute for me, please?
Yes, sir.
Are you, what's the nature of your concern? You ask a question because?
I don't know how you get to that, sir.
Mhm. All right, so don't ask me the question and then leave me like that. I want you to work with me. Look at this. 2 over x. The law of indices says 1 over a to the positive m. Were you in class last week, Chanel?
Yes, sir.
I know I wrote it last time. I'm just being lazy instead of going to rewrite it, just to copy it. But I know I did it though. I know I did it.
I think your computer was giving problem at the time.
Oh, it's true, you know. Talk truth, and I was typing something it never saved on.
Right.
Yeah. Yeah, I had a senior moment just now. All right, number 13. Let's go back to number 13. All right. All right, so recall 1 over a to the positive m is going to be equal to a to the negative m. And let me just there put 1 times a to the negative m. So my numerator does not change. My numerator is unchanged. It's just a denominator that I'm moving. So this a to the positive m, I'll take it now to the numerator as a to the negative m. This is indices. This is where I started off with you. First thing, October 25th. Not sure if you joined us then, but yeah, let's go. Where am I? I'm right here. 2 over x, the variable. This variable is raised to the first power, x to the first power. Just like this one, that does not change. My 2 also does not change. So the 2 is fixed. What changes is that this x to the negative first power becomes x to the negative first power. Moves from being a positive to now being a negative. See here? Moving from being a positive to now being a negative. Can you see that, Chanel?
Yes, sir.
Can you
I'm
agree
here.
with that now, Mommy? All right. Can you agree with me with that now?
Yes, sir.
All right, watch me now. Negative 1 times 2 is a negative 2. And I'm reducing the power by 1. Negative 1 minus 1 is equal to negative 2. We never normally write our index as a negative power. So I'm going to reconvert it and put it back into the denominator so it becomes positive. The negative 2 is fixed. It does not move. What moves is my x to the negative second power. That goes into the denominator, so it's now x to the positive second power. So this is what it is. Do you see that?
Yes, sir. See it now.
Right, thank you. All right, don't move too far away now. Still stay with me. So the other term is going to be negative 3x times x plus 1. Negative 3x times x plus 1. This is a product. The product rule says the first times the differentiation of the second plus the second times the differentiation of the first. The first times the differentiation of the second plus the second times the differentiation of the first. The first, negative 3x, see it here, so, times the differentiation of the second, which is my parentheses, which is going to be 1, plus the second, which is x plus 1, times the differentiation of the first, which is negative 3. Negative 3x times 1 is negative 3x. This negative 3 I am putting in front here, removing this multiplication sign. I'm putting this negative 3 in front of my x plus 1, like so. This negative 3x here is the same negative 3x here. I'm now distributing this negative 3 over my x plus 1. So negative 3 times x is negative 3x, and negative 3 times a positive 1 is a negative 3. My 3x's are the same, so it's negative 3x minus 3x is negative 6x minus 3. So I'm putting all three together as 12x squared minus 2 over x squared minus 6x minus 3. And that's my final answer. So
did you put two different rules in one question?
that's not true. I can put many more rules in one question. Can you do that one for me, please? Yes, Tani, you can get questions like this on the exam. They can mix it up. Start for me, please. Number 14. Finish?
No, sir.
Yes.
Finish?
Yes, sir.
Yes, sir.
All right. Let us together work it out. Johnny, finish?
Soon finish, sir. Just in the last part.
Hurry up. Give me the first differential that you got.
2 cos.
Huh?
Sir, I got 3x squared cosine x raised x cubed.
Very good. So the first term is going to be 3x squared cosine x cubed. The differential of cosine is going to be sine. Differential of, sorry. That was a joke. Differential of sine is going to be cos. The differential of sine is cos. The differential of cos is minus sine. So when I differentiate sine x, I'm going to get cosine x. Now the differential of sine x cubed is going to be cosine x cubed. But I now need to differentiate the function, which is going to be the differential of x cubed is going to give me 3x squared. All right, so that's the first step. Then the other one is going to be 326. 6. All right, I'm doing this mentally. So I'm going to get negative 6 over x cubed. Anybody got that?
Yes, sir.
Yes, sir.
And then the other one now is going to be the first. Let me put this in parentheses. The first times the differentiation of the second plus the second. Oh no, come on, don't do that to me now. The first times the differentiation of the second plus the second times the differentiation of the first. Look and tell me if you get that so far. Is
Yes, sir.
nice. It's going to be 3x minus 2, 3x plus 3. All right. I'm doing this rather very quickly, so tell me if I am right. 6x plus 1.
Sir, wouldn't that be a negative 3?
I will tell you in a few. Where?
Where I have the positive 3 open bracket x plus 1. In front of the 3x minus 2, there's a minus sign. So wouldn't that make the everything else in the bracket change?
Yeah, so did you get negative 6 minus 1?
Yes, sir.
Come on, sit here, the same thing. So
Oh,
this
oh,
negative sign
okay.
is going to multiply everything here.
I never realized I had a minus sign.
Yeah. All right. So let me just explain this level of mathematical maturity now. So, and you will see it as you start doing more questions, guys. Log on to your Edicosoft. Your Edicosoft has quite a number of these questions that you can practice with. So what I did was to factor out my constant, which is this -1, and just differentiated this function. And each time I kept my function, my negative sign, as a factor term and differentiated everything. You know, when I'm finished, I can then distribute this negative sign to get -6x minus 1. And that will be my final answer. Are there any questions? Anybody not seeing how I got it? Everybody okay with it?
Sir,
Yes, sir.
sir, how did you get the 3 for the last term?
This 3?
Yeah, no, up top. That right. Yeah, the second line. Where did you get the 3? The last 3.
This 3 here? Or the
No,
last 3? The differentiation of the first. Remember, it's a first. So I write it back. Times the differentiation of the second. Remember, this is the first and this is the second, you know.
Okay.
Times the differentiation of the second, which is 1, plus the second, which is x plus 1, times the differentiation of the first, which is 3.
Okay, thank you.
No problem. I thank you too, Chanel, because I mean, it's the first time I hear you kind of showing up in class and talking and asking questions. Very nice of you. I love it. Find another question China asked me.
So between one of the negative.
Aniki,
Sir.
you heard what I just told Tani a while ago? What you got for your, before you answer that, what did you get for your answer, Nikki?
I mean, it's already first part, then -6x minus 5.
-6x minus 5.
Yes.
No, I know. All right, let me just double check something because I know where you guys are getting. You're putting this as a -3, so that's you're adding the -3 to the -2 to get -5.
Yes,
All right.
sir.
So as watch me, honey. Watch me, honey. Watch what I'm doing. Watch what sir doing. You see, I'm dropping my parentheses in front of my negative sign here.
Yes, sir.
So I'm differentiating inside here. So first, excluding my negative sign. So why did you do that? Let me hear your thinking, sir. I did that because I would have to distribute this negative sign into one of these parentheses. And I said to myself, so you know what? Let it stay because it just means that this product is negative. So I take out the negative sign. When I take out the negative sign, watch me. The derivative of c f of x is going to be equals to c, and to find the derivative of f of x, c is a constant. So what the man them do? Them now differentiate the constant. Them draw the constant out and put it in front of the d of x, and then just differentiating f of x. See here? Draw the constant in front and differentiating f of x. You'd have seen me do this many times over. So that's how I'm treating the negative sign as a constant, the -1 as a constant. And then now, when I differentiate everything now, then I multiply this constant by my differential. Get me?
Yes, sir.
So that's what I'm doing here. I'm taking my negative sign out. When I differentiate, I'm going to have the first, which is 3x minus 2, times the differential of the second, which is going to be 1, plus the second, which is going to be x plus 1, times the differential of the first. I'm differentiating the first, I'm going to get 3. So this 3 multiplied by the x plus 1 is going to give me 3x plus 1, 3x plus 3, sorry. And then I'm going to have 3x minus 2. My 3x plus 3x is going to give me 6x, and my negative 2 plus 3 is going to give me positive 1. When I multiply this negative signs throughout, now I'm going to end up with negative 6 minus 1. All right?
Sir,
Yes, please.
sir, how you get the first 3?
All right. Which first 3?
Sir, before,
This,
cause 3x squared.
this,
Yes, sir.
this one?
Yes, sir.
Remember, the differential of sine is cosine. So but hear how I'm saying this, and I want all of you to listen to me, because I'm going to say this for the final time. I want all of you to listen to what I'm saying. Generally, the differential of sine x is cosine x. Generally, the differentiation of sine x is cosine x times the differential of x, and the differential of x is 1. So the differential of sine x is cosine x. The differential of cosine x is going to be negative sine x. So when I differentiate cosine, when I differentiate sine, I am going to get cosine. But I have to write out my angle. Remember, I can't trouble the angle. There is no way I can trouble the angle. All right? I cannot trouble the angle. So now I have to differentiate the angle. And the differential of x cubed is going to be 3x squared. I'm waiting on you to tell me, yes, sir, I see it.
Yes, sir.
You sure?
Yes, sir.
Mm.
Wait, sir, one more thing, sir. When I put the denominator, which would be x squared, and then I square that, sir, the 2 squared them would cancel out each other.
No, because I'm going to differentiate the denominator. And when I differentiate the denominator, we end up with a 2x. And one of that x's, the x in the numerator will cancel with one of the x's in the denominator. Watch me. I'm not going to do it now, but just watch me. The denominator times the differentiation of the numerator. The differentiation of the numerator is a constant that goes to 0. So what I'm going to be left to know is minus the numerator, minus 3, times the differentiation of the denominator, which is 2x. So minus 3 times 2x is going to be negative 6x. So think of me having negative 6x up here. All over the denominator squares, which is 2, which is x squared square, which is x to the 4th. So I'm going to have minus 6x over x to the 4th. One of the x's up here cancel with one of the x's down here. So I'm going to have 6 over x cubed. You see that, or that just fly over your head?
Yes, sir, I'm saying it.
Okay. Is there anybody else in the class that don't see that? If you don't see it, use a quotient rule and do this one, and it comes back to this. Trust me. But let me tell you what I recognize though. And this is based on, is an observation based on what Mrs. Henningham was doing in class tonight. You guys know the rules. Me now worry about unknowing the rules. You know the rules. But what I find is that you're not practicing the rules enough. And if you don't practice it, you're going to lose it. Me know if you ride bicycle, you know. Me used to ride bicycle. I'll ride bicycle and ride up in a one bus and drop off. You should ride bicycle. The other day, me decided to go on one bicycle for a ride, and trust me, it was the hardest thing ever. You know why? Because it's long time I don't ride a bicycle. What's the point, sir? If you don't understand to do something and don't practice it, we're going to have a challenge. Serious challenge. To overcome those challenges, you have to practice. You have to practice. You must practice. All right? I want to know it. I listen to the conversation. My 3 sons and my many daughters in here were answering my questions. Matter of fact, one of the sons, them not their class tonight. Oh, him reach. Matthew, you come class too late nowadays, you know, Matthew. You log on too late. And you're missing out. All right. Let me see if I can. So Tani, so you agree now that I can give you a chain rule question with a power rule in here, because technically this is a power rule, a quotient, and a product. And also involving something trigonometric. Can you see that?
Yes, sir. Sir, like what you did the first one, I'll just follow what you did
Just
to
follow.
get the answer.
Fair
Yeah.
enough. Fair enough. Okay. I am going to give you, that one to do for me. Number 17. I want to see how well you do that. And that's the last one before I move into another aspect. Start that one for me, please. My side, what one? Finish?
No, sir.
Say, this is very hard.
My side, my side, my side. What keep? Finish? Okay, I don't think my device is working so well. And as such, you not hear me. Johnny, Oyster.
So, so yeah,
Mhm.
the two working at the same because when I sure all the on the other
And you know why? And that's why I want to hear from you, but nobody's speaking to me. I deliberately put this one here because this one is if you're not paying close attention, you can get sidetracked. I'm going to give you 3 more minutes, all of you, just to double check and to just finish off the question, and then we'll go through it. And then I'm moving into something else. All right, 3 more minutes. My side. My side, my side, my side. Team STEM. Team STEM. Talk to me. Want to reach? All right. No problem. Fine. Javier, where are you?
Sir,
John Mark? Go ahead. Go ahead, Javier.
tell the truth. Me will pay for it.
That's
Me do
not
what
nice.
you know, but me just stop cause.
All
Just
right.
stop
Aniki, all right, never mind. Aniki, where reach?
I do something, but I know I say wrong.
Okay, all right. Shanti, where reach?
Sir, that's an answer.
You got an answer?
Yes, sir.
Okay, and what is that answer?
Sir, 64x cubed plus 120x over. Sir,
Over what, Shanti? Kamisha, John Mark, Kasana. Kasana, you promised me. You promised me. And then you renege on your promise.
So what is it, sir?
You weren't here Saturday.
So I came. I'm not going to
And
lie, but I did not stay.
I'm going to beat you. I'm going to put across my, I'm going to beat you. Matter of fact, I'm going to make Mrs. Henningham beat you. She have a thicker belt than me.
No, I never waste my time. I did end up go study something, but it might not be your subject though.
All right, I hear you. Kimoli. Answer.
Sir,
Talk
my
to you.
answers are long and far-fetched.
Talk it.
Sir, I have 8x, open bracket, minus 60x to the fourth, minus 64x squared, minus 18x plus 24 over 8 minus 6x squared to the fourth.
All right, thanks, Timmy. I know piece of it is right. Matthew, what you say?
Sir, me no know now. The answer.
Matthew. Me not like your movements from the other day, you know. Me not like you. Me not like your movements from the other day. You now move right. All right, Papa, I hear you. Natty D, what say you? Is the book not come class tonight? Natty D, what say you? All right, you're a no
Sir,
show.
I don't have an answer, but I tried.
You tried, okay. Katrine, how you stay?
I don't have an answer, but I tried something.
All right. Foxy. All right, you're a no show. Chanel, how you stay?
Sir, I tried, but I'm not too sure about my answer.
Katrine?
sir,
How you stay?
sir, already.
Oh, yeah, I did. Yeah, sorry. Forgive me. Emilio, did you answer me? Emilio, how you stay? Talk with the man, time running. Tanisha, how you stay?
Sir, I started and then I stopped when it started look wrong. So
How do you, if you know say it look wrong, that you know how to correct yourself?
no,
Think about
sir,
it.
that no mean
No,
no.
no. Think about it. I want all of you to think about it. If you know say it start look wrong, that means you know what to do, so correct it.
Sir,
Correct it, man. All right, I hear you, mommy. Tani, what you stay?
Sir, I did something.
Tati D, how you stay?
Sir, I'm okay.
Tell me answer then, since you're okay. Talk to me now. I'm taking too long, you know. Tati G, how you stay? Okay. Some of them are pill me, you know. Some of them are pharmacists. I'm a pill in the eye. And I don't like taking tablets. All right, I think I've called everybody. I'm hoping I did. All right. Take a few minutes, look through, and then we can start the conversation, having completed the look through. Let me know where I went wrong.
Sir, I can explain what I'm going right to say.
Say it again, Papa.
Can I explain the working out we do right to say?
All right, sorry, no, you're very low, Matthew. Speak up for me, please.
May I ask you can explain the working out we do right to say?
All right, no problem, my pleasure. You see, let me tell you why I gave you this question. And it ties in beautifully with what Tanil asked me at first. Oh, sorry, I never know you could get all of them something they're mixed up together. Here, what is happening? Mrs. Henningham can't see round the corner. Mr. Sean can't see round the corner. Papa Jesus are the hungry one that can see round the corner. Where are you going with that, sir? He's the only one that knows what is coming on that exam paper. We, Mrs. Henningham and myself, have absolutely no clue. So I have to every now and again drop a little one question where I know we're in bold. I know this question was going to bowl you. I think I don't know. Why think I tell you 5 minutes? Anytime you hear me say 5 minutes, you can say, the one that got long. Sir never said 2 minutes, sir said 5. Come, let's go. The denominator, x minus 6x squared all squared, the denominator times the differentiation of the numerator. I'm now differentiating the numerator. The differential of a constant is equal to 0 every single time. The differential of 2x to the fourth is going to be 8x cubed. See here, 8x cubed. Minus the numerator, minus 2x to the fourth plus 5. I'm going to put it in parentheses. You know why? Because I have more than one terms in my parentheses. Had it been just a single term in the numerator, I didn't have to put it in parentheses, right? So I'm going to put my 2x plus 4, 2x to the fourth plus 5 in parentheses. Times the differentiation of the denominator, the power rule comes in play right here. So it's going to be 2 times 8 minus 6x squared to the first power. See here, 2 times 8 minus 6x squared to the first power. I'm reducing it by 1. And then now I have to multiply by the differential on the inside. That of a constant is equal to 0. That of negative 6x squared is going to be equal to negative 12x right here. So all over the denominator squares, which is just squaring this piece. All right. The differentiation ends right here, so in my first line. What is left now is just simple algebra. Simple algebra. I'm putting this 8x cubed in front of my 8 minus 6x squared. This 2 times negative 12 is going to be negative 24x. And negative 24x times this negative sign is going to give me a positive 24x. And I'm writing back my 2x to the fourth plus 5 times 8 minus 6x squared right up here, so. And then now I am not going to be distributing. So, oh goodness, I was trying to remember. I don't know who, was it JV or one of them said to me that sir, my answer is long and gave me one long something. We're not going to be expanding out this something. Never, I keep saying it to you, you never try to expand your denominator. Never. It's when you see the numerator like this, watch the trick. Watch this. It's when you see the numerator like this with something on one side that is common to something on the other side. And worst case that you see it in the denominator, factor it out. Every single time. Don't expand it, factor it. So I recognize that 8 is common to 24, and that x is common to x cubed, and that 8 minus 6x squared or squared is common to, sorry, remember I'll take out the smaller of the two, right? So that's why I'm taking out 8 because it's smaller. And that's why I'm taking out x because compared to x cubed, it's smaller. So that's why I have the 8x. 8 minus 6x squared compared to 8 minus 6x squared, it means that 8 minus 6x squared to the first power is smaller, or yeah, smaller. So I'm taking out those three things: the 8, the x, and the 8x, the 8 minus 6x all squared. Then I'm factoring out. Let's go. What do I multiply by? All of this to give me all of that. And you'll recognize it to be an x squared times the 8 minus 6x squared. Why, sir? Because I have only one of the 8 minus 6x squared, and I need another one here. Indices come back in play. We're making the connections for you. When I'm multiplying and the bases are the same, I add my powers. A to the m times a to the n is going to be equal to a raised to the m plus n. I did say to you that indices is going to come back to haunt us every single time. So when I multiply these two terms, I'm going to end up with my squared term here, and 8x times x squared is going to give me 8x cubed. Let us move over. What do I multiply by 8 to give me 24? It has to be 3. What do I multiply by x to give me x? That would be 1. So 3 times 1 is 3. Good. What do I multiply by 8 minus 6x squared to give me 2, to give me all of this? Of course, you know that is only going to be 2x to the fourth plus 5, which is why I have it here. Then now I can fix up this term because there's nothing common here and there's nothing common here. So that's how you know you're going to expand. So how do you know you expand? Why did I not expand all of here? Because this is something common here, so that is common here, so that means you can factor it out. Oh, so once we can factor out something, so we'll factor it first and then the what left will expand. So the what left here now? So I'm going to say x squared times 8 is 8x squared. X squared times negative 6x squared is going to be negative 6x to the fourth. Again, indices says when I'm multiplying and my bases are the same, I add my powers. x is the base, another x is the base, the power here is 2, the power here is 2, I write back the base x, and I add 2 plus 2 to give me 4. 3 times, I notice I'm able to distribute this x squared over this parentheses. Why? Because it's raised to the first power. I could not have multiplied 8x cubed by 8 to give me 64x to the third power. No, because the power is not raised to 1. The power is raised to a number greater than 1. So I can't do that. All right? And then 3 times 2x is 2x to the fourth is going to be 6x to the fourth, right here, so. And then 3 times 5 is going to be 15. You notice them 2 here cancel out? So I'm going to be left with 8x squared plus 15, which is that, all over x minus 6x squared to the fourth power. Now this one here will cancel out one of these. So all I'm left with is 8x times 8x squared plus 15 all over this. Then, sir, why never just multiply this by that? I could have, but that did enough work right here, so, and the man them see me know my factorization. So I'm leaving my answer in a factored form here. So the answer is going to be 8x times 8x squared plus 15 over 8 minus 6x squared all cubed. If you choose to expand this at this point in time, hooray for you, you get the same number of marks. I need to hear your comments, where it is that you went wrong. If you see where it is that you went wrong, ask me your questions now. I'm dedicating no more than 5 more minutes. I must introduce another topic to you tonight. Háblame, 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 háblame.
Sorry, I did this faster than my brain could process.
What I know is where I went wrong was the fact that I didn't factorize in the second step. Right there, so.
Okay, fair enough. Anybody else? And guess what? A long time you're a teacher, so when I get a comment like what Tani said, that sorry, did it so fast that my brain couldn't process it. I'm not internalizing that because there's something I'm going to ask Tani to do for me now. So Tani, while I'm asking the other students to give me their comments, I'm going to ask you to go at your pace, look through the question, honey bunches, and tell me if you see what is happening. And then we can have that conversation. All right? Now, I need to hear from the rest of you, you know. I don't want no spectators in my class tonight. I need to hear from the rest of you. Háblame.
Sir.
Yes, Papa.
To expand out the 8 minus 6x squared, yes, I get the same marks.
If I expand out what? This times this?
No, I'm not talking about the 8 minus 6x squared, where the factorize. Now ask if you expand it out and work it out the other way, you get the same marks.
Way too many steps in that, Papa. And when you do that sort of expansion to bring all the terms together, you increase the likelihood of you making an error. And what it is that you'd have done. So if the differentiation here, if this question here carries 8 marks, and of the 8 marks, you get 4 marks for here, and then the other 4 marks for this 1, 2, 3, and to write it in a simplified form. You make an error right here, you throw away those 4 marks and only get 4 to 8 when it is that your differentiation is correct. So it's not differentiation that is failing you, it will be algebra. So I'm suggesting to you, don't go through and do this multiplication. Matthew, if it makes you feel better, that's what I used to do when I was doing this in high school. When I was doing this in high school, this is exactly what I used to do. Exactly what I used to do. And then now, when I reach my final answer, because there's so many x squared and x cubed and x to the fourth and so forth, at some point in time, Mr. Sial, watermelon and piece of KFC chicken in the question. And even though my differentiation was correct in blue, and I should have gotten full marks for the question, I'm getting only half as much because of careless mistakes in the in-between, right? So see if we can get into the habit of factorizing, Papa, please. Next.
Sir?
Yes, I didn't factorize and I just stopped at the first part because it looked like it got too long. So I'm just if do it kind of look hard.
All right, fair enough. Now,
So you can go over about the second line. No, the third line, please.
right here,
Yeah.
all right, I'm coming to you, honey. Let me just say this to you. Let me say to you. I remember when I was studying on campus, and this is a story that I want all of you to take something out of it. Every one of you to take something out of it. I remember when I was studying on campus, I was doing a course that, oh my goodness, I fell in love with the course. A math course, as a matter of fact, fell in love with the course. And every opportunity I get, I just went and looked at the course. It was a beautiful course, well put together. And I understood it inside out. And what the teacher gave me, his soul rest in peace, one of the best math lecturers the university has ever employed, Professor Robinson. And I'm going to tell you, Prof came to class and Prof taught. And Prof taught. And I understood the course so well. So when I went into the exam, I froze. Didn't know what to do. I know the worst thing I could have do. Turn around and looking at the exam room and see everybody else at work and me can't start work. Jesus, Father. And them start sweat. Me start perspiration, I drop on the exam paper. And I just started freaking out. And I remember what the university does is that they have master students invigilating the exam and PhD students. And when I sat down and just didn't know what to write, couldn't do one bit of, not everything was just gibberish. Me couldn't read a question. I don't know what the question is asking. And I'm saying to myself, but I performed so well in the course. I mean, I did very well on the mid semester, the course term exam. I was like, what happened? And I just sat there and I said, okay, fine. I'm just going to fail this course and just move on. And I remember one of the invigilators came over and said, what is the problem? Why not working? I said, I'm blank. I said, I am blank. And the invigilator came and said, she said to me, take your time, recoup, and do what it is you're supposed to be doing. And then Prof walked into the assembly hall. Oh goodness, that dreaded place. Walk into the assembly hall and say, why are you not working? I said, I'm blank. He says, boy, start working. I said, okay, sir. And I just needed that affirmation. And I started working and everything came to me. And I did. And I did. Suffice it to say, I got an A for the course. I got an A for the exam and I went into the exam with an A. I'm not saying to you that, oh, I'm bragging that I got an A, but I'm going to tell you what, this is a lesson that I want you to get from it. You see how sir gave us the questions on the mid-semester and in class, so forth and so on. Upon the final exam, it were different. So what I went into the exam expecting to be was far from it. No, I lost quite a bit of time, more than half an hour I lost out of a 2-hour exam. But when I got my composure, because I knew the course so well, I was able to do the question in about 1.5 times less than the hour, about 3/4 the time or 2/3 the time that I got, and I was able to complete the exam. Nonetheless, when I said complete the exam, did every single bit of the question that was asked. Got an A for the course. What's the point? The point is not me saying that I got an A for the course. The point is, me no know where CXC I got sent on the exam something. But anything them say, keep your composure. Remember what Mrs. Henningham would have done with you. We taught you conceptually so that you understand the nuances of what it is that you're doing. You know the songs that I've taught you. Follow them step by step. My side, you can't fail me. If you follow me step by step, you're good to go. Now look at how the question, but sir never teach you the question away. You forget about it. You see the something, and them say differentiate, and them tell you about, oh, chop the up on top of the hill and roll down and so forth and so on. Okay, fine. tough luck, sad story, but you know what it is. Take the function and differentiate it. You know what to do. So I don't want anybody, and I did this, deliberately. I'm going to tell you why. I have my cheerleaders in the class that will speak to me and will give me answers. And I want my cheerleaders not to feel discouraged, but to recognize that I need to do a little bit more with my preparations, because it's not how Mr. Shan give the questions, I write questions out of my head and present to class. If you had me for a face-to-face class, you will see me come to the classroom without a textbook. I'll just come and I know what I'm teaching, and I'll just make up the questions. And I deliberately make up very difficult questions so that when you go into the exam, you are fully prepared. Let's go. And I really hope you get the message what I'm saying. The message is not about me getting an A. The message is I sat in an exam and wasted more than half an hour because I did not know what to do. Kept my composure. I know I put in the work. It came back. I finished the paper within an hour and a couple of minutes. Finished the question paper. Finished the exam. When me write, look back at me, people still, not write this time because they run out of ideas. Come on. The question says, y is equals to this ugly looking thing. Sir, you never give nothing like that. So I don't care. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. I gave you that. And that's what it is that you're going to be using to evaluate this ugly looking thing. Let's go. The denominator, you call it, you write it back. See it right here. So times the differentiation of the numerator. Look on the numerator, you know the differentiation of a constant is equal to 0. So you're going to differentiate the next one. When I differentiate 2x to the fourth power, I'm going to get 8x to the third power. See it right there. So 8x to the third power. Minus the numerator, I'm going to write a minus sign. I'm going to write all of the numerator back right there. So 2x to the fourth plus 5. See it right there. So 2x to the fourth plus 5. Times the differentiation of the denominator. I'm going to write my multiplication sign. Differentiating the denominator. I must, at this point in time, recognize that I have the power rule. Once the something is raised to a number that is greater than 1, like the one here, raised to the second power, power rule, power rule, power rule. Once it's not raised to 1, look here, this is not the power rule, because it is raised to the first power. So if it is not raised to if it is raised to the first power, it's not the power rule. But once it is not raised to the first power, it is the power rule. So because this is not raised to 1, power rule. You take that one here, fling it in front of yourself, see it yourself. Then you're going to reduce the power by 1, 8 minus 6x squared to the first power, see it right there. So. And because it's a power rule, we're going to differentiate on the inside. That of a constant is equal to 0. And when I differentiate negative 6x squared, I'll get negative 12x. See it right here. So all over the denominator squares. 8 minus 6x squared, squared. You know the law of indices that says a to the m raised to the nth power is going to be equal to a to the m times n. We've done this. We've done this. The law of indices says a to the m raised to the nth power is going to be equal to a to the m times n. So that 2 here, I'll go multiply that 2 here, and I'll go give me 8 minus 6x squared to the fourth power, right there. So all I'm doing is fixing up this 8x cubed, I'll just put it in front. This negative 1 times 2 is negative 2 times a negative 12x is going to give me a positive 24x. See it right there. So I'm going to write back this 2x to the fourth plus 5, right there. So I'm going to write back this 8 minus 6x squared, right there. So I'm taking my time. Come on my side. That side is easy. From here, so make a reduction it even further. But hold on, sir. 8 minus 6x squared is common to 8 minus 6x squared. So we can factor out something. Once you see that we can factor out something, do not expand. Factorize it. Once you see something is factorizable. Factorize it. That is your hint. When you say food, eat it. That's your hint. When you have plenty money, spend it. When you see something that is common, factorize. That's one of the foundational rules to work in mathematical questions. Simplify it. When you factorize what it is that you're doing, you're simplifying your stuff. So I recognize that my 8 minus 6x squared is common. And always remember, I'm taking the smaller of the two. So the one that I'm going to take out is going to be 8 minus 6x squared. See it right here, so. But I also recognize that 8 is a factor of 24. Every number is a factor of itself. But you check to see if it's a factor of another number. Yeah, man, because 8 times 3 is 24. So we can take out all of the 8. I take out the smaller of the two every single time. And between x cubed and x, yeah, man, x is a factor of x cubed. We take out the smaller of the two, so I'm going to take out the x also. So in total, what I'm taking out is 8 times x times 8 minus 6x all squared. My task is now to investigate what is left. What is left? Watch me. You get a pair up here, so you take out the essential. Food money, first thing you take out is the tithes, then your food money, and then all our bills. So the bills part look big. Yeah, man. What is left is what it is that you can say, okay, we can go a Burger King, we can go a KFC, we can go a Devon House, and we can go on praise party down at church. So if you go fix up right now, you what left? Is there anything that is common this side, that is common this side? Talk to me. In the what left?
Sorry,
Is
do
there
it
anything that
again.
is common? In the what left? Is there anything common? Anything common here that is common there?
So x and 2.
Look at
Oh,
my
just
factor term. Is there anything common here? Remember, this is multiplied by this, so you can't just say x is common. Is there anything common here that is common here in the in its form that I have it written there? Say no. Somebody.
no.
Right. So there's nothing common. So the mere fact that there's nothing common there, because you see, there's no x squared on the outside that is common to an x squared on the outside, or a 3 that is common to this. And definitely nothing in my parentheses here is common to anything in my parentheses here. So x squared is common to x to the 4th. You can't separate it because this negative 6x squared is married to this 8 in the parentheses. That's why it is contained in the parentheses. And all of this now is going to be affected by this x squared outside here. So I can't say, sir, x squared is common to this x. No, I can't. I can't. So the mere fact that I said there's nothing else that is common, I can go ahead and expand. X squared times 8 is 8x squared. X squared times negative 6x squared is negative 6x to the 4th. 3 times 2x to the 4th is positive 6x to the 4th. And 3 times positive 5 is going to be positive 15. Them two you cancel out. Concretizing the point that I'm making, that there is nothing that is common. Them two you cancel. All I'm left with is 8x squared plus 15. Nothing common. And because nothing more is common, this is my final answer. Are you with me, guys?
Yes, a little.
No, I'm finding it a little, you know, because I'm moving on from here. Your responsibility is to go and look back at this question. If you
So the
understand
question, all right, understand, it's just that line. I understand everything else except for that line.
I
The
would
third
suspect that
line.
you can understand it anyway. Based on the level maturity that you take to this class, I expected you to understand it. So if you told me that you didn't understand it, I would be disappointed. I would have said, class done. And there are others in the class that I expect to understand this also, but they are very silent. Matilla Forrest, you are one of those. I'm going to shake out your lunch money for the rest of the week. Watch and see.
So I'm going to say.
It's what you don't do. That's the problem, is what you don't do. All right, never mind. Come, let's go. All right, so having cuss you off in a nice way, in the Christian fashion, there is no love lost, you know. But, you know, in any relationship, you know, you're going to, I mean, if you think about your parents may say, call your names or say something to you. It don't mean say your parents don't love you, you know. It's better than one from you. So sir will come to class and telling you off very nicely, but read into it, sir is not pleased. But there's no love lost. I'm trying to get you in this very limited time that is left for the exam to a place where it is that you can perform at your optimal level. All right? All right. I'm not going to go through any more of these. I will send them up as questions for you to do because we have other things to take care of. Now, a thought came to mind to give you a bit of screen break, but I don't have that time. So, forgive me. When you go, we are going on bathroom break, and you're not able to go to the bathroom because you haven't lab them to do. So let's go. I am moving on to an
question.
Yes, son.
Sir, question. Sir, for the second step, all you did was just factorize like one side of the question from the 24x to the end. You just factor it out in pieces for the third line.
Yes, yes.
Over
Yes.
this, okay.
Right here, son.
All right, I get it now.
Yeah, man. I just factor it. You see, because I can't see everything one time, I just look piece by piece until I get everything out.
Yes, sir, because it makes sense because the 24 is multiplying by this. Okay, I get it.
Absolutely. Absolutely. Thank you. All right. So maybe I'm only able to go through the explanation, and one of the things that I bring to the table, teaching that is, I believe if you introduce a topic very well, it makes you appreciating the topic a little bit more, you know, digestible. And hear me trying to attempt giving you an introduction to an application of differentiation. It's called stationary points. It's an application to differentiation. It's called stationary points. Now, stationary points, and we are looking at a single variable function, because best believe, after I've completed this, I'm going to look at the multivariable function, where I'm going to talk about squiggly y and squiggly x, and them all squiggly looking sort of squiggly things. Now we're talking about the single, and squiggly talking about only a partial derivative. All right? So it means that I'm not differentiating the function fully, I'm only differentiating piece of the function. All right? In this case, now we're talking about single variable functions. Single variable functions, you have your y equals to something else, or your f of x equals to something else. When I move into multivariable function, I'm going to have f of xy equal to things in x and y. And you have to do the stuff separately. All right? If you were in my calculus 2 class, they do multivariable function with 3 variables, f of x, comma y, comma z, and they have to differentiate it squiggly, which is a partial derivative. All right? So if you understand the single variable function, it makes life so much easier when we move into the multivariable functions. Watch me. And please note again from our introduction to differentiation that y is equal to f of x, and that f dash of x is going to be equals to the same thing as dy by dx, and f double dash of x is the same thing as d squared y by dx squared. I could have gone further to say f triple dash is equal to d cube y by dx cube, but this question, this topic, only takes into consideration the original function in y. Then I have to find my derivative, first derivative, and then when I'm going to do some classification, I will need to find the second derivative. So this line should not be new to anyone. Now, to determine the stationary point, I'm going to go through this stuff. You may not see it until I start doing a question, but I must talk about it. To determine the stationary point, we need to differentiate the function. You're doing a calculus question, and on the exam paper, the questions will set up in its module. So you're going to see module 3 calculus. So once you see and you're going to get 2 questions. You're getting 6 questions to do. 2 questions under each module. Now, when you get the module under calculus, of course, one of the questions will be differentiation, and the other question will be integration. All right? So differentiation and then integration. So you will see the question, you'll know which question is differentiation. If you can't pick up the first part of the question with differentiation, just read through the other piece of the something they must ask you something about differentiation. I know that question is going to be differentiation. They're not going to mix up the differentiation with the integration. They will give you a differentiation question fully, and then they move into an integration question fully. That's how I see they set the paper. If I'm wrong, you can find it and show me, and then I'll come back to you. But based on what I'm seeing so far, differentiation is 1 question in section 3, and integration is another question in section 3. All right, let's go. So you're going to differentiate the function. When you differentiate the function, you're going to set the derivative equals to 0 and solve for the unknown. And then this is going to give you the critical values. So you're going to get the function. You get a function y equals f of x. You're going to differentiate the function. When you differentiate the function, you're going to then set the function equals to 0. And when you set the function equals to 0, then you're going to solve for the unknowns. When you solve for those unknowns, those will give you critical values. When you get those critical values, you're going to substitute them into the original function, not the differentiated function, but the original function y equals f of x. And you're going to get the corresponding points. Now, those corresponding points together will call my stationary points, or my critical points, or my turning points. All of them mean the same thing. And it's going to be written in my coordinate form, x, y. So that's how you determine stationary points. I wrote this summary because I want you to have it. Differentiate the function, set it equals to 0, solve, substitute into the original function, you have your critical points, your turning points, your stationary points. Then, sir, what is stationary point or critical point? Mrs. Enningham thinks she's a wicked driver, you know. And Mrs. Enningham leave her house and reach halfway and remember say the stove on, and she said, oopsie daisy. And she turned the car around and she said, oh, Mr. Shot, a wicked driver, you know. And good wicked that is. And when me turn the car now, me not stop none at all. No, miss, you did stop. Even a nanosecond, you stopped. Because when me stop, she's not changing direction. That's what we call stationary point. At some point in time, she reach her maximum speed and she have to stop right there, so, and then go around. And trust me, none of the best and the brightest drivers can turn the car around without stopping. Even a nanosecond, that car must come to a halt, or else you and the car will tumble down. All right? So that's what we mean by stationary points. Critical point, turning point. So you can understand maybe turning point because you're turning around. But another name for turning point is critical point. And another name for critical point is stationary point. All right? And then now, to classify the nature of the stationary points, and I could call it critical point or turning point. All of them mean the same thing. I don't know which of the points CXC will use. If them say stationary points, let us move with stationary points. But what if them say critical point? We'll move with critical point. What about turning point? We do the same thing. All right? So if you hear me reference to stationary points, it means that I'm talking about all of them nonetheless. So to classify my stationary point, I'm going to be using the first differential and differentiate it a second time. And differentiate it a second time to obtain f double dash of x. So to determine the critical point, I'm going to find, and there are 2 ways I'm going to teach you this. This is the first way, my method 1. I didn't read method 1, but this is my method 1, right? I'm going to use the second derivative. Then I'm going to set the second derivative equals to 0. And I'm going to substitute the critical values. No, I'm not going to set it equals to 0. I'm going to substitute my critical values into my second derivative. When I set the second derivative equals to 0, I'm finding the point of inflection. I don't reach a point of inflection yet. So here, I am going to be, when I obtain the second derivative, I'm going to look at my critical point, my stationary point, my turning point, and I'm going to substitute that value, or the value x, y, into f double dash of x. If the result is greater than 0, then I have a relative minimum. If the result is less than 0, then I have a relative maximum. If it equals to 0, I have a saddle point. If it is equal to 0, I have a saddle point. I'm just telling you that, I'm giving you that bit of information. All right? It says differentiate products and quotient, polynomial sine, cosine, e to the x, ln x. We've done that. Then my last piece on 2.8 says determine the stationary point of a given function. It says maximum and minimum points and point of inflection. Maximum and minimum points and point of inflection. It did say that I don't need to, come on, man, sure. It says obtain the second derivative. Yeah, I just talked to them about that. Investigate the nature of the stationary point, maximum and minimum points. It tells you when that is greater than 0, minimum, less than 0 is maximum, equals 0, possible a point of inflection. And it says f double dash is equal to 0. Use a test the sign of gradient on either side of the stationary point to determine its nature. You know, somebody reads up with them say, saddle point is not, hold on there. Me swear me they read something with them say saddle point is not necessary. What a good thing somebody included. I was about to tell you that don't worry about saddle point because it's not a part of the syllabus, but no, that's integration. So this is a multivariable function. Or point of inflection of the multivariable function is not included. Oh, okay. All right. No problem. No problem. So if f double dash is equal to 0, possible point of inflection. So I need to talk to you about the point of inflection here. But for the multivariable function, point of inflection is not included, but it's included for the single variable. All right. That's what I have to be doing, guys, jumping in and out of the syllabus to make sure that we are doing what we are supposed to be doing. All right. So yes, so if f double dash of x is equal to 0, then we have a point of inflection, which is a saddle point. And I'll show you what that saddle point looks like when we start plotting the graphs of these stuff. All right. Now, method 2 is that I'm going to be using my graphs, right? I'm going to be evaluating, and I'll show you the examples below how we use a graph. If the graph points upwards, looking like a U, the parabola turns upwards, and in foreign we call it parabola. If the parabola turns upwards, you know that it's going to be a minimum graph. If the parabola turns downwards, you know it's going to be a maximum graph. All of this you should know from CSEC math. All right. I will come back to it. I'm just glancing over that because that was a recall. I'll come back to it. Now, to determine the points of, to determine the intercepts, I'm sure I did something like that very recently. But anyhow, the intercepts, no, it's not you, I did it with you, whatever. To find the y-intercept, you put x equals 0. To find the x-intercept, you put y equals 0. Watch this. Watch this trick. To find the y-intercept, I'm going to put the other variable equals 0. See the y-intercept here? I can't put y-intercept and then put y equals 0. It has to be x equals 0. And if I'm evaluating the x-intercept, I have to put the other variable y to be equal to 0. So to calculate the intercepts, it's pretty easy. To determine the intercepts, it's pretty easy. They ask me to find the y-intercept, we put x equals 0. They ask me to find the x-intercept, we put y equals 0. Pretty easy. And then the point of inflection, we have to do the point of inflection for the single variable function. Watch me. We're going to use the second derivative and set it equals to 0. And we're going to solve for the value of the unknown. Solve for the value or values of the unknown. When I get that, I'm going to substitute it into the original function. And then I'm going to write down the coordinates, which is in the xy form. Now, please note that the point of inflection occurs between two critical points at the midpoint. I remember when I was doing midpoints with you on the graph, when I was sketching some graphs. Anybody remember when I was sketching graphs and I said to you that there's going to be a point of inflection, and I said to you a little later on in calculus? I don't know if anybody remember what I said right there, but anyhow, I did say that a little later on we're going to come back to this. This is where we're finding. So I'm saying to you, by point of observation, you will see that if the question has one critical point, then there exists no point of inflection. It only occurs for a continuous function. And then we're going to be asked to sketch those graphs, right? Now, I know it's 8:30. I'm going to beg you no more than 10 minutes. I'm going to go back through this again with you. but I want to go through this example so that I can send it off to you tonight or by tomorrow, because I kind of feeling tired now. So at least you can have it to play around with before class on Friday. All right? Please and thanks. Thanks for agreeing. It says, given the function y equals x squared minus 6x plus 1. It's a very simple question that I'm starting off with. All right? Now, it asks me to find the critical points. Sir, I remember, to find the critical points, I'm going to differentiate the function, set it equals to 0, solve for the unknown. Sir, you say it so fast. That's exactly where I want to get it. Differentiate the function, set the derivative equals to 0, solve for the unknown, substitute it into the original function, and together the x and y value when they give me my stationary point. So remember, there are 4 things to do to find the stationary point: critical point, turning point. Differentiate the function, set the function equals to 0, solve for the unknown, substitute it into the, and those are going to be called your critical values. Substitute those critical values into the original function to get the y coordinates. And together the x and y will give my stationary points, critical points, turning points. Watch it with this one. Really not difficult. Nice topic. Nice application to differentiation. Y is equals to x squared minus 6x plus 1. We're differentiating. Differentiate this function for me, please, and tell me what you get.
2x minus 6.
1, 2, 3. 2x minus 6. That's the derivative, 2x minus 6, right? When I get my 2x minus 6, I am then going to set it equals to 0. See here? 2x minus 6, set it equals to 0, solve for x. When I solve for x, I'm going to get x equals 3. That is my critical value, x equals 3. X equals 3 is my critical value. When I get a critical value, I'm going to substitute it into the original function. What's the original function, sir? See, Tessa? X squared minus 6x plus 1. So that's why I'm saying put x equals 3 into x squared minus 6x plus 1. Anywhere in the function I see x, I'm putting 3. 3 squares minus 6 times 3 plus 1, I'm going to get y to be equals to negative 8. So putting this as my x value and negative 8 as my y value, here goes my critical point. 3, negative 8. Critical point is finished. That's how easy it is. Differentiate the function, set the function equals to 0, solve for the unknown or unknowns. That will yield me my critical values. Substitute those critical value or values into the original function, and what comes out will give me my coordinates. My coordinates would be my critical point or points, stationary point or points, turning point or points. All right? Watch me. We did curve sketching. And if we got this question, remember, anybody remember we did this thing, we wrote it, completing the squares? H is equal to B over 2. Yes, man. Yes, man. And H is equal to B over 2A, we're going to get negative 3. And when we find K, which is equal to C minus B squared over 4A, we're going to get negative 8. Same vertex that sir told you about earlier on. I cannot review this. I don't have time to review. But we have done this. We would have gotten our 3, negative 8 nonetheless. So you see, when sir taught you this completing the squares, what sir was teaching you was really differentiation and to find the critical points, right?
Sir, so can do anyone?
No. And I will tell you why I said no so quickly. Because sometimes when you get most times when you get the questions are of the cubic form. This is how they normally give you your critical points. But I started off with example 1, very simple, because I wanted to get the hang of it. But most times this is what they're going to give you. I mean, when they give you in the cubic form and the cubic form. Let me see if I have another question. Yeah, and the cubic form here, so you can't use this, because this is only done for the quadratic. Can you see that?
Yes, sir.
Yeah, man. It's only for the quadratic that you can use it for. And I guarantee you they won't give you a question with x squared. I only chose this question because I wanted to bring across this point in particular and also do something pretty quickly so that we can just move through. All right? All right, so I have 5 minutes. So let me just review this quickly. I'm differentiating the function, easy differential, 2x minus 6. Set it equals to 0. solve for the value of x equals 3, that's my critical value. Put it into the original function. What I get out of it is going to be -8. My critical point, therefore, is going to be 3, -8. All right. Then the second part of the question says the coordinate of the y-intercept. Oh, y-intercept. Which one are we going to put equals 0?
X equals
X. X. Remember, you put the opposite one equals 0. So if there's a coordinate of the y-intercept, you put in the opposite one equals 0. So since it's a y-intercept, that means x equals 0. Look at the original function. Anyway, you see x put in 0. That is 0, that is 0, that means y equal 1. So we have 0, 1. See just so? X is 0, so you have 0, y equals 1, you have 1. As easy as that. To find the intercept, the y-intercept, you put x equals 0. The x-intercept, you put y equals 0. Easy 1, 2, 3. Are there any questions to that part 2?
No, sir.
All right. Part 3 says, determine if the critical point or points is or are a minimum or a maximum. Okay, no problem. That means I need to find the second derivative. When I find the second derivative, I'm going to substitute the critical point, which is 3, -8 into it. If it is positive, it's a minimum. If it is negative, it's a maximum. If it is equal to 0, it's a saddle point. So we are taught about substitute the critical point into the something. If it is greater than 0, positive, it's a minimum. If it is less than 0, negative, it's a maximum. If it equals 0, it's a saddle point. Well, you notice the syllabus didn't mention it as a saddle point, but a point of inflection. It names saddle point. Once it equals 0, is a saddle point. All right. So let's go. Let us check this question. So I'm finding the second derivative for part 3. So recall dy by dx is equal to 2x minus 6. When we differentiate this function here, we got 2x minus 6. I now need to find the second derivative. And the second derivative is going to be d squared y by dx squared. D squared y by dx squared. When I differentiate 2x minus 6, do you agree that the answer is 2?
Yes, sir.
Yes, sir.
Right. Good. So what it means now is that this question is tricky, because what it means is that in my second derivative, anywhere I see x or y, I'm going to substitute 3 for x and -8 for y. Am I seeing any x or y right in here, sir?
Yes, sir.
No, sir.
I'm not seeing any value. So it means they can't take nothing. This is like a constant. And the differentiation of and the limit of a constant is the constant itself. So therefore, the -2 here are going to be -2. And it's a positive negative, it's a +2. So it's going to be +2. So because this second derivative here is positive and I have no x or y to substitute, I'm going to carry this +2 as my value. And because it is positive, it's a relative max, a minimum. It's a relative minimum. Remember, when it's positive, it's a minimum. When it is negative, it's a maximum. All right. So I can say that my critical point 3, -8 is a relative minimum. Minimum. That's my stationary point. Minimum. And when I sketch the graph, the question says now, sketch the graph of y showing all the points. The critical point 3, 8. Right here. So it wants me to show the y-intercept 0, 1. It wants me to show the critical point here, that is a minimum. Let us sketch the graph. This is what the graph looks like. When I sketch the graph, the minimum point is the lowest point. So watch now. Miss Henningham, I go on working and she go on good enough. And Miss Henningham drive a Lamborghini and she drive the Lamborghini and I drive the Lamborghini. And when she reach right, she said, geez, peas, me have to turn back. And when Miss turn back, this here is going to be her minimum point right here. So if you look careful at it, if this is 5, that means this is 1, this is 2, this is 3. No, you can stay with me, out of order. Stay with me. 1, drink some tea after class. I soon finish. 1 more minute. 1, 2, 3, 4, and see the 5 right here. So this is going to be 1, 2, 3. So we catch that 3, yes or no? We catch that 3 right here. So we could see if we can catch the 8. This is 0. This is -5. That means we go down by 1. -5, -6, -7, -8. So I get my -8. So when I plot the graph of y squared, of y is equal to x squared minus 6x plus 1, or yeah, whatever it is, plus whatever it is. This is the shape graph I'm going to be getting, right? On the graph, I can see my minimum point, 3, -8, and I can tell you that this part here, where the graph crosses the y-intercept, rubbish, where the graph crosses the y-axis is going to be my 0,1 because my y-intercept is going to be at 1, 0,1. This piece here is actually 0,1. See it here, so this is 0,1. So I ended up showing all the things. Now, a minimum graph is a parabola or parabola, whichever one you want to call it, that shape upwards. Upwards is positive, it's minimum. Downwards is negative. Downwards is negative. Like the one here, downwards is negative. How you spell negative? N. Don't the piece look like one N? Say yes.
Yes, sir.
Yes, sir.
Yeah. So N for negative. N for negative. So this is a negative piece of graph. This piece here, so because it curves downwards. But the piece here is positive because it curved upwards, right? So in some of the sketches, Tanil, you will have piece be negative and piece be positive. All right? Piece be negative and piece be positive. And that's what it is. I mean, this is a pretty easy version of the question, but I gave it this because I want you to see what is happening. So just to say something pretty quickly, I know this is very quick and I will go through again, but I wanted to go through this so that when you look at it on your own, you can say, oh, I remember sir saying this.
So, sir, is there any chance that they will give us an easy one like this in the exam, you know?
To be honest with you, let me tell you what I think they're going to give you. I think they're going to give you a cubic function. A cubic function. But guess what? If they give you a cubic function, it's not any different from the one that I did, because to find the coordinates of the y-intercept, what are you going to do right here, so? Can somebody tell me the coordinates of the y-intercept right here, so? Quick and fast. Hello, somebody. What's the coordinate of the y-intercept here, so? When you find the y-intercept, what do you do?
X equals 0.
Yeah, man. So you put x equals 0. And when x equals 0, 0, 0, 0, how much y equal to? Negative 7. So the coordinates of this y-intercept is going to be 0, -7. You see how much mark you get already? Out of the question, you just look on the question and you can't tell them the answer. The critical point, you differentiate the function. When you differentiate the function, you set it equals to 0, you solve. Now, let me pause and say something right here, because my factorization of my trinomial comes back to haunt you. See it right here, so you have to now factorize your trinomial again. So those of you who struggle with trinomials when I was doing completing the squares, see this something here come back to haunt you. So you have to go study that. So that's why I believe, yes, they will give you a cubic one. So it's the same thing. Critical point, you're going to differentiate the function, set the function equals to 0. You're going to get your critical values, substitute the critical values into the original function, and then you're going to end up solving for your, you're going to get your critical points, right? In order to get that, determine if the critical point is a maximum or minimum, you're going to find the second derivative. And for each critical point, you're going to substitute the second derivative into the differential piece. And if it is positive, it's a minimum. If it is negative, it's a maximum. Equals 0, it's a saddle point. Determine the point of inflection, you're going to differentiate the function, the second derivative, set it equals to 0, solve for x, substitute that x value or x values into the original function in y, and the corresponding value will give you your coordinates, and sketch the graph and it done. These are the 5 things that they could possibly ask you for the question. So the only thing that is going to be different is the function. So you think we're going to get that x squared function? No. I think they're going to give that x cubed function. So will they give us that x to the 4th function? Absolutely not. So it's one of 2 options. Either to give that x squared function or to give you an x cubed function. All right? I'm going to pause right here. Thank you for staying on with me. I'm going to suggest something to you though, guys. Please and thanks. I really want you to think about this for the remaining 3 weeks that we have before your exam comes into play. That I may beg you, yes, miss, thank you. I may beg you for for about a half an hour. So instead of us ending at 8:30, think about it. Don't give me a response now. Think about it. That, come Friday, we'll go up until 9 o'clock. And starting this Friday and the other Mondays and Fridays that are left for the semester, we'll go up to 9 just to try and get in some more time. I spoke with Sir today about the SBA, and Sir promised me faithfully that, Sir, I'm going to, when as soon as I finish this task, I'm going to touch back base with it. I said, Sir, remember, the SBAs are due in the teens. He asked me for the data. I got the data. I sent off the data. But I guess there are so many other deliverables that are coming up. I'm going to be speaking with him tonight again to get the stuff. Now, let me tell you what is going to happen. What we are trying to do, the pair of us, Mr. Russell and myself, we're going to be extracting the data, and we are going to be working the data for you, present the data in a readable fashion for you. And then we'll come to class and we will analyze the data together. Now, when we come to class and we sit down in class like this, you see, when we're analyzing the data, we know nobody says, oh, sir, it's 9 o'clock, we have to go. Because when we're analyzing the data for the SBA, we may be here up until 10 o'clock. Because remember, we are helping you with the SBA. That's why it's called a school-based assessment. But you also have to put the work in, right? Remember, we're doing an accelerated program, so I can't give you any and everything to go and do. So we have to guide you through this SBA. So we are going to be working the SBA. We are going to be extracting the data rather. Then we are going to come to class, and together we are going to be working to do the calculations. So he will do it with his class. I'll do it with my class. I will show you how to do your how to set up the SBA in terms of your methodology, your method of data analysis, how it is that you got the data, so forth and so on. And then in your groups, you are going to sit down. I'm going to teach you the topic and teach you how to analyze and what information you can get from it. And in your groups, you are now going to go and do your analysis of your data. So I'm going to be working with the same data in class because I don't want you to go and do time is really against us. So I will work with the data, the set data that we're going to be using for the SBA. I'll work with those. We can get our stuff. I will give you other examples of how it is that we analyze the data. And then I'll then ask you to go ahead and analyze your data for the SBA. In your groups, we have to put students in groups. And guess what? I was thinking of putting 3 people per group, but it may very well be 5 per group because of the nature of what is happening. We're trying to reduce the number of SBAs that we have to mark. Chances are we may have 1 day to mark the SBAs. Now, let me tell you something. It's those of you who are suffering from lazy man-ritis, this is not the time. Because we don't have the time for the stuff. And if my son want the SBA, when I forgot sit up in our groups and work on the SBA tonight, forgive me tomorrow morning, for mark it, forgive them the following morning or later on that day, we want the SBA in Jesus' name. Time is against us. It is not our fault. The exam results came back late and we started school on the 25th. CXC is not saying anything to us and them still want them SBA in April or so. And we have to do what we need to do. So please, students, when I said to you, go and analyze it in a group and write something, all of you will come together and make one writing. When the SBA is finished, what is going to happen is each of you will have a copy of the SBA. The SBAs will be the same for all group members. The only thing that is going to be different is your cover page. You will have your cover page with your center number, your registration number, the school, the name of the lecturer, etc., and the topic. All right? Each of you will have a different cover page, but the contents of the SBA is going to be the same, and we will indicate on the sheet that these persons were in group 1, group 2, group 3, so forth and so on. When we do this, remember, we are not doing the SBA for you. What I am trying to do for you, or what we are trying to do, Mrs. Henningham will be part of the process also, is to help you with the analysis of data because of the limited time that we have. When we do this, I suspect and expect that you guys participating and doing what it is that you're supposed to be doing will end up with a very good SBA grade. When you go in the exam, go fail it, and see what happens with me. On Friday, I really want you to think about us just putting in a little half an hour more so we can just get this thing sorted out. I have started they call it. All right, I'm getting tired now, so I'm start talking foolishness. I've started watch me, because I don't even remember where I start. So just watch this on the screen. I have done, well, not that I'm not going over it again, but I've introduced the stationary points of a given function and make sure write the notes so that you can see what is happening. Talking about maximum and minimum points. And then 2.9 talks about the second derivative. We work a question, just know where we found the second derivative. And we're going to investigate the nature. So technically, unit 3 is, unit 2 here is finished. I'll go through more of these questions. So on Friday, God's willing, I must start my multivariable function, where it's going to talk about the concept of the average rate, the rate of change. And then I'm going to go all the way down to, again, you'll see whether or not a function is increasing, decreasing, pretty easy. Cost, revenue, profit function, pretty easy. Your cost is going to be equals to your revenue plus the this and your profit and all of them. Pretty easy stuff. 10 minutes can take care of you with that. And then I'm going to be moving into next class, my partial derivatives. See here, squiggly f of x, squiggly y, squiggly xy. Did say that I'm not supposed, right? And it's polynomial. Oh, see here, Shante, polynomials of degree 3, right? So I'm not going to get anything with degree 2. I'm not going to get nothing with degree 2. It says polynomial of degree 3. So don't expect that one that I gave you. That one was only to whet your appetite. Polynomial of degree 3. Now, when I finish this multivariable function and then something there, then I'm going to start my integration. And integration is going to be the last topic on the calculus. And then I'm going to move into my my statistics, but I'm going to be very specific with what it is that I do in the statistics. And this is regression, and this is what we're going to do the SBA on. Oh Lord, help me. Anywhere along here. Nope, not there. Investigate linear regression, correlation, regression line, anywhere from 5.9, correlation, summary statistics, interpret the value of correlation, draw an estimated regression line, determine the equation of regression, use statistics to solve real-world problems. So this is going to be a real-world problem that we're solving. We're looking at the pass rate of CXC Math and CXC English. I believe that's what we got. And then we're going to interpret the results using statistical calculations. So the SBA is going to be on 5.9 to 5.15.
So,
When we
so
do
we're
the
going to do
SBA,
all of this in 3 weeks?
yes, miss. Did I not say to you that we don't have time? We're doing all of this in 3 weeks, and that will be the end of the statistics unit. So I'm actually starting at the end of the statistics unit. There are 5 units in statistics. I'm going to start at the end of that 5 units. The other units, I may or may very well not be able to go through all of that. I did say this to you, and that's why I'm saying to you, go through your Edicasa, but some of you playing stocky, right? So at least you can work ahead of me. So when we start in the stuff, we can get it good and proper. Measures of central tendency. I will go through all of that with you. But just to, Mrs. Henningham reminded me with the SBA, that's why I'm just saying all of this to you. Guys, I did say to you that time is of the essence. We are doing an accelerated program. I feel bad about it, but there is nothing more that we can do. And that's why I'm begging you this half an hour per class starting Friday. Think about it, come back to me and let me know. Plus, we will continue meeting on a Saturday. If it means that I'm doing something different with the calculus students, I'll put you into a breakout room where it is that I can get 4 more hours in with you on the weekend. We have to do what we need to do, guys, in order to make it. All right? We've spent a long time tonight. I thank you. See, we take the half an hour from tonight already. Oh Lord, forgive me. Thank you, guys. Say your prayers, dear gentle Jesus. Just ask the Lord to just cement everything that was done tonight. I know we did a whole lot. Just ask the Lord to just, work it out into your favor, and you'll be fine. Remember, he who fails to prepare should prepare to fail. And to whom much is given, much is expected. Of him or her, much is expected. So we are expecting much of you guys. So please don't fail us. Thanks for coming out. Thanks for listening. Thanks for participating, and have yourselves a wonderful rest of the night. All right?
Bye, sir.
Bye, sir.
Bye, sir.
Hi, sir.